Welcome back to another episode of Mr. Myers Mini Math Lessons. Hope you're enjoying your show. Today we're going to be learning about the least common multiple and finding the least common multiple. We've already talked about multiples. We've already talked about common multiples and how to find common multiples. Today we're going to talk about the least common multiples. Okay, so again, it has to be a common multiple between two or more numbers. We're looking for the smallest one. Okay, now, when we do this, we're going to use very much the same skills that we use for the prime factorization and the greatest common factor. Okay, but there's a little twist, a little thing that we add at the end. But once we have the greatest common factor, we basically have the least common multiple set. We just have one more step of multiplication to do, and that is it. So let's take a look here. It says find the least common multiple of 4 and 12. All right, so just like finding multiples and finding common multiples, we could just do 4 and 12 and start listing our multiples, right? Start counting by 4. 8, 12, 12, 24. Oh, there's our least common multiple. It's the very first common multiple. We can absolutely do that. We can absolutely, especially when the numbers are this small. Please don't set up the whole thing if you're doing it with numbers this small. Just start listing the multiples and find the smallest one. Okay. Hi. Awesome, thank you so much. So please don't feel like you need to set up the whole thing for numbers this difficult. All right. You're going to want to use these steps when the numbers get bigger and bigger and bigger, but I'm going to show you with these numbers just so it's a little bit simpler to see. All right, so set it up just like you are going to find the greatest common factor of these two numbers with your upside down division. Again, pull out the smallest prime number. They're both even, so we can pull out a 2. 4 divided by 2 is 2. 12 divided by 2 is 6. They're still both even, so we're going to pull out a 2. All right, 2 divided by 2 is 1. 6 divided by 2 is 3. We've reached a 1. We are done. All right, so this is what we would do if we're finding the greatest common factor. Right, and all we'd have to do is we'd have to multiply these two numbers. Correct? That's all that we would do. And the greatest common factor of 4 and 12 is 4. 2 times 2 is 4. GCF is 4. But they're asking about the least common multiple. What I'm trying to show you is our work for the least common multiple is basically done. All we have to do, instead of just multiplying the left side, we're going to multiply all of these numbers. Do you see what shape that makes? Let me make that a highlighter, actually. Highlighter, yellow. We're going to multiply those numbers. What shape is that? It's an L, right? It's an L for least common multiple. 2 times 2 is 4. 4 times 1 is 4. 4 times 3 is 12. Our least common multiple is 12. And isn't that what we got when we started listing 4, 8, 12? 12. 12 is our least common multiple. Another really cool thing about the least common multiple is it helps us find all the other common multiples. I'm never going to make you find all of them, but it helps us find more. Right? Once I know for 4 and 12, I know that 12 is my LCM, my least common multiple. So any other common multiples, we just start counting by 12s. Let's just take a look. 4, 8, 12, 16, 20, 24, 28, 32, 36. All right, for 12, I'm going to do 12, 24, 36. If I were to just count by 12s, I would get 12 as a common multiple, our least common multiple. Another 12. 12 plus 12 is 24. It's our next common multiple. Our next one is going to be 36. Do I have to start listing more 4s, or should I just start counting by 12? So what would be the next common multiple? Hopefully you said 48, and then 60, and then 72. Once you've found the least common multiple, start counting or finding multiples of that number, and that's going to be your common multiples. Very good. All right, so on this one, again, the numbers themselves are easy, right? 8 and 10, it'd probably be easier to start listing 8, 16, and so on. But let's just work through the process. 8 and 10, upside down division, they're both even. Divide by 2. 8 divided by 2 is 4. 10 divided by 2 is 5. We have neighbors, we're done. If I were to find my greatest common factor, this is a good one just to talk about real quickly. The question doesn't say what is the greatest common factor of 8 and 10, but let's just say it did. There's nothing here to multiply. We only have this 2 on the side. So in that case, the greatest common factor is just 2. If there's only one number over here, that itself is the greatest common factor. Okay, but the question is asking for the least common multiple. All right, so again, we're going to make the L of all the numbers outside of our division.
Mike, please contact the office. Mike, please contact the office.
Okay, we need to multiply these numbers together. 2 times 4 is 8. 8 times 5 is 40. 40 is your least common multiple. Let's do another one. Find the least common multiple of 6 and 15. Look, I finally did an odd number for you. 6 and 15. Can I pull out a 2? Absolutely not. Even though it fits into 6, it does not also fit into 15. The number you pull out has to fit into both of them. So if 2 doesn't work, I should check what number next. 3. 6 divided by 3 is 2. 15 divided by 3 is 5. Okay, I'm done. I have 2 prime numbers. They're not going to fit into each other. This prime number does not fit into that. We are done. Okay, if I were trying to find the greatest common factor, it would just be 3. Right? If I was just trying to find the greatest common factor, but I'm actually trying to find the least common multiple, so I'm going to make an L of all my numbers outside of my division, upside down division bars, and it's 3 times 2 times 5. 3 times 2 is 6. 6 times 5 is 30. 30 is my LCM. Let's take a look at this one, 24 and 36. How many people want to sit here and start counting 24, 48, right, and keep going that way? Not many people want to do that. So what they're going to want to do is this upside down division. 24 and 36. They're both even. Pull out a 2. 12. 18. They're both even. Pull out a 2. 12 divided by 2 is 6. 18 divided by 2 is 9. Are they both even? Can I pull out another 2? Nope. Can I pull out a 3? Absolutely. 6 divided by 3 is 2. 9 divided by 3 is 3. We have neighbors. Okay? If I wanted to find the greatest common factor of these 2 numbers, I would multiply these together. But am I looking for the greatest common factor, or am I looking for the least common multiple? The least common multiple, so I need that L. Okay, and I'm going to multiply those numbers together. And if you have to do the numbers out, do the numbers out. No big deal. 2 times 2 is 4. 4 times 3 is 12. 12 times 2 is 24. 24 times 3, 24 times 3, 12, 1, 6 plus 1, 72. 72 is your LCM. There's no shame in doing math on the side. There's no shame in getting the right answer. There's no shame in doing whatever you need to do to get the right answer. So if you are comfortable with greatest common factor, you should be comfortable with the least common multiple, because all you have to do is multiply those other numbers that are not there, or that we didn't use for the greatest common factor. The hardest thing about least common multiple and greatest common factor is keeping them straight. It's the greatest common factor, the least common multiple. It's confusing. I get it. The greatest common factor is actually a smaller number, where the least common multiple is actually a bigger number, right? Because multiples are numbers that multiply, and factors are numbers that fit in. So even though it's the greatest common factor, I get it. It's confusing. Just know this. I'm not that mean. And I just say that mean, because I will never make you find the greatest common multiple. The greatest common multiple is not a thing. That goes on forever and ever and ever, and you would never stop, and you'd never get the answer. I'll never make you do that. It's the least common multiple, the greatest common factor. Go ahead and practice. Just kidding. Right, so this is just another example. If we try to do this on the last example, greatest common factor of 64 and 48, this is all the work done out. All we have to do, right? A lot of times, and the reason I do this, I'm sorry, let me explain a little more. The reason I do this, a lot of times it says, find the greatest common factor of 64 and 48. And then the very next question will be, find the least common multiple of 64 and 48. Please don't redo everything. Use this work, right? You use this part over here to get you your greatest common factor. 2 times 2 is 4, times 2 is 8, times 2 is 16, right? So your GCF, or your greatest common factor, is 16, right? And then the next question, just show me. Be like, Mr. Meyer, nice try there, buddy. Not that much work left to do, right? It's this times this. Even if you just wanted to do 16 times 4 times 3, that would work too, right? 16 times 4. All right, we have 4, carry the 2, 4, 64. 64 times 3, 12, carry the 1, 18, 192. There's the least common multiple. You want to be counting by 64s and 48s to get all the way up to 192? Think there's a very good chance you might make a little mistake on your adding as you try to find those multiples? I think so. Please try this method. Practice it. It actually got nicer. My very first year of teaching, I didn't teach people how to find the least common multiple like this, and I would make them find the least common multiple of the number 13 and 17. And they were given no calculators. They were given no information on how to do it. I just said, find the least common multiple. And so they would start listing all the multiples of 13 and all the multiples of 17. They had to do it on their own. It took a whole class period. And with 5 minutes left, I would stop them and I would say, hey guys, why are you not done? Right? And I would go up to the board and say, all right, here's your trick. And I would do the trick. And they would get so mad at me because using this method, it's a lot quicker. Let's take a look at what happens here. We have 2 prime numbers, if you notice. 2 prime numbers. There's not a single number I can pull out of here that's prime. When this is the case, when you have 2 numbers that are prime, okay? Or you have 2 numbers that don't pull out, they might not be prime themselves, but there's nothing there. Let's say I said, find the least common multiple of 5 and 9, right? When I do this, there's no number to pull out. There's no number to pull out. This is what's called relatively prime. When they don't share any common factors, they're relatively prime. It's not that there's no least common multiple. All you do, multiply 5 times 9 is 45. There's your least common multiple. If they're relatively prime, meaning there's nothing, no small common prime numbers you can pull out, just multiply the numbers together. That is absolutely going to work. They have to be relatively prime.